Hi, everyone. We are having a very interesting video today to show you how you can build real-time context for your Gen AI agents using DeltaStream. My name is Hojat. I am the founder at DeltaStream, and I have Rick here. Rick, please introduce yourself.
Hi, I'm Rick.
Yeah, Rick is one of our engineers, and we are going to be talking about, as I mentioned, context and especially real-time context for agents and how we can build it in DeltaStream in a very easy way and make it available for your agents. Let's go to the second slide and give a high-level overview of what we are talking about. So once you are building agents, of course, these agents are going to use LLMs as their brain, but they also need to understand the context and know what's happening around them to be able to make correct decisions. As we move from simple agents that just look into historical data and answer questions and summarize documents and those type of scenarios, to more sophisticated agents that can monitor events that are happening around them and based on those events take action or provide the right next steps or analysis for the data. We will be needing the real-time context for this. And the context can come from a variety of data sources. In this example, you see that your data can be in relational databases, streaming systems like Kafka, or lakehouse systems like Iceberg. And your agent is going to need to curate this data and runtime and be able to make it in a way that it can be used to analyze the data and prompt the LLM in a proper way. So what we are seeing here is that we are going to use DeltaStream as the real-time context engine, meaning that DeltaStream is going to be able to ingest data from a variety of data sources, combine them, correlate them, aggregate, transform, and prepare the context that continuously is being updated and make that context available for your agents in real time through its built-in MCP server. Once you build the real-time context, which under the hood, it is a ClickHouse table that's continuously being updated with link jobs with subsequent latency, you will be able to make these contexts available, not for one agent, but a variety of agents. And it includes governance and access control. So your agents only are going to be having access to the context that they are allowed to have access to. Having said that, let's go to the next slide, Rick, and see what would be the steps to build this. So as I mentioned, it's a very simple scenario in DeltaStream. Assuming that everything is set up and you have access to DeltaStream, you will be able to build the context through pure SQL statements, correlate, join, aggregate, transform your data. Once you build that context, you will be able to create a specific access token with the permissions that you specify. And once that token is created, you can make this context available to your agents as a tool. And once it's available, your agent will be able to take actions and make decisions based on fresh data, not stale data. And that's going to be, in many cases, the difference between a working and useful example and something that would not be working properly. So for this video, we have prepared an example that would be very resonating for a lot of folks who are in the security space. So if we go to the next slide, we can talk about the high-level scenario, and I'll have Rick to explain the steps to implement this use case end-to-end. So you will be implementing a security copilot that ingests data from or needs access data to a variety of sources that events happening, auth events, network flow events, IDS alerts. And here in this example, we have a few of them, but in real scenarios, these could be like 20, 30 different data sources that you have to continuously ingest, correlate, transform, prepare data, and make it available for your agents. Of course, your agent can directly connect to these services and pull data in real time and do all of these things itself. But the moment that you want to do these things, you add a lot of complexity spanning from access control for a variety of systems to latency to robustness of this process. Imagine your agent wants to access 20 different MCP servers and all of those things. So in many of these use cases, it's better to kind of like proactively prepare the context by joining, aggregating, correlating all of these information, and just have a prepared data available for your agent that with one access, it can have all of the context that it needs. So with that being said, let's try to implement this end-to-end use case with DeltaStream. And I believe for building the agent, we are going to use Agent Builder from OpenAI, but we are agnostic for any platform that you build your agents. So in this example, even though we are using Agent Builder, this applies for any other platform from Agent Core and Bedrock or other platforms. All right. With that said, Rick, go ahead.
All right. Thanks, Ojay. So first off, I want to point out that much of this information comes from a blog post that we published a couple of weeks ago. So if you're looking for more detailed information outside of this video, we can probably link this in the description and you can see sort of the details at your own pace. But first off, we will go ahead and jump into DeltaStream. Ahead of time, we've declared our store. We have a number of topics on that. In this case, we have a data gen running to sort of give us some synthetic data. So the first thing we're going to do is declare some streams on top of these topics. And let's go ahead and grab our auth events. So you can see here we have this auth event stream that we're declaring. It just tells DeltaStream the shape of the data that's flowing across this topic. So we'll go ahead and run that. And then I've got the same for network flows and IDS alerts. So here you can see we have network flows, IDS alerts. So we'll go ahead and run those as well. And so,
and of course, as we discussed, you can have tens of these data sources that you can declare streams or change logs on them, and then process them in DeltaStream.
Absolutely, and just for simplicity's sake, we're just keeping the number small, but you know, in the real world, you'll probably have many more sources than that. So now we're going to go ahead and launch our first enrichment query, where we are going to be joining the auth events with network flows on the source IP addresses. So we'll go ahead and run that. And two things are actually happening here. So number one, we are declaring a new stream, which is the auth flow enriched. The second is that it's launching a long-running job in the background. That's we run Flink out of the sheets, and that is processing these events immediately as they flow into your Kafka topics. And then let's launch another enrichment query here. So this one, we are joining the IDS alerts and the auth flow enriched streams together again on the source IPs. And we'll go ahead and kick that one off. Okay, and then finally, we are going to create our materialized view. And Hoja, do you want to talk a little bit about through this one here?
Yeah, once we correlate all those three streaming sources that we have, in this materialized view, we create different metrics for our data. As you see, we are counting failed authentication events for a given window of time. We can calculate the multi-factor authentication usage. So these are the different metrics that you can compute, and sky's limit for you. You can add as many different metrics and different decision-making factors included in this context that you're building. And as you see, we are defining it as a materialized view here, which is backed by a ClickHouse table. So the idea is that you're ingesting all of these events in real time and building this real-time context and continuously updating it. Once this is built, this materialized view as a real-time context will be available for your agents that Rick is going to show how it can easily have access to it. So if you run this, it's going to be a continuous query in our backend system.
Okay, so perfect. So we'll jump over to the queries page here, and you can see that we now have 3 different queries running: 2 enrichment, and then our materialized view query. So those are starting up. And while that's happening, we can progress on to the next step of this demo. And we will go over to the OpenAI agent builder, and we will create a new agent. Okay, and we'll start off.
Let's name it SOC Copilot as the one that we have.
And then let's go ahead and in our blog post, we have a nice little description that says you are a senior security operations center analyst. You have access to real-time security context materialized view named security risk context MView provided by DeltaStream. And then it goes on to provide a bunch more information for this agent to use when it is operating. What gets to be interesting here is down in the tools section, we're gonna hit the plus, and I'm gonna add a new MCP server. Say server, and I am going to add the MCP, the DeltaStream MCP endpoint, DeltaStream we'll call it, and we'll jump back to the DeltaStream UI. We're going to click on the integrations tab, say create a new one, SOC MCP agent, and we're going to say expires in 7 days. And right now we're going to just use the sysadmin role for sake of brevity, but in the real world here, one of the beauties of our solution is that when you create an API token, you can assign a role to that token. So anytime that token is used, it only has access to the resources that are granted to that role. So in reality, you can create a role, call it MCP role, and give it access to only the specific views that you want to expose. And that sort of tightly contains the blast radius of what the MCP server can actually access. So here we have our API token. We'll go back to the agent builder, and I'm going to paste that in here. And we're going to go ahead and say connect. So now it's the agent builder made a call over to DeltaStream to say, hey, what tools are available? And here you can see the security risk context materialized view is the only one that's showing up there. And then we'll say never require. And we're going to add that one. And that's all there is for setup. Before we do continue on, let's go ahead and jump back to DeltaStream real quick, make sure that our queries are up and running and everything's ready, and then we can launch our agent here. So back in DeltaStream, if I can find the tab, we'll go ahead and take a look at queries. They are all running. Let's just go ahead and launch this and give her a go. Okay, so let's go ahead and ask my agent, what is the highest risk users right now?
So this is the main difference between having access to real-time context and stale context. Because now agent can exactly know what's happening right now. But if your context is 5 minutes late, 10 minutes late, it cannot have any clear idea about what's happening now, and of course cannot take any action that's meaningful, because the actions are going to be based on 10 minutes, 20 minutes ago's data.
That's exactly right. So we have the immense power of an LLM plus the real-time data that is fresh from now, right? So I think those two pieces together is where it gets to be a really interesting story. So here you can see it is flagged Bob, and he has a lot of failed logins. His risk score is quite high, and you can see that apparently Bob has a lot of problems going on here, but we'll attribute that to mostly data gen. So let's go ahead and ask, why did the risk spike for a specific IP in the last couple minutes? And let's go down here. And it is sometimes interesting to look at the reasoning that happens here. You can actually dive down in a little bit and you can look at the MCP interactions of the agent client and the MCP server. So here comes back with an answer saying it spiked because the recent window, this IP is a surge in authentication problems, high critical IDS alerts, by data transfer, so on and so forth. And then it also calls out the specific users with those problems. So again, this is super interesting to be able to have real-time data and your agent is able to digest that information for you on the fly.
One important point I want to ask, this context that we built, it's a stateful context, meaning that the scores are calculated for certain window and those type of cases, or the correlations and joins are based on this window of time. If you didn't have this context built proactively, your agent had to connect to all of these different resources directly through MCP and to do all of these correlations and stateful correlations and transformations and aggregations itself, which in runtime, it would not be, in many cases, would not be a reasonable way to do it. So building context proactively and making it available significantly can improve access control and governance for the data, latency for your agents, and of course, simplifies building the agent in general. Great. Well, as you see, in a very short time, a few minutes, we literally built real-time context through DeltaStream queries and exposing it through DeltaStream's built-in MCP with the governance and access control included in it to our agent. And the only thing that we needed to do is just tell agent that the context is here. And you can easily see that in these type of scenarios, for instance, for security copilot that we just built, without having that real-time context, everything that agent would do would be based on stale data, and it wouldn't work as it's expected to. So a very good way to show that in many use cases, many sophisticated agents, having access to real-time context is make or break for those type of scenarios. All right. I think we're going to wrap this up here. If you have similar use cases that you're building agents that need access to real-time data, real-time context, would love to hear from you. So go to our website and contact us. We would love to talk about your use cases and see if DeltaStream would be a good solution to help you in building those agents. But having said that, we really believe that the next wave of agents are going to be more sophisticated, proactive, real-time agents that can ingest the real-time context and take actions based on those. And we are very well positioned to help to build those type of agents. Thank you very much. Thanks, Rick.
Thank you.